let's find out what is factor theorem. Now we have done a great deal of study on what is remainder theorem. We have seen that remainder theorem says that if Px is any polynomial of degree greater than or equal to 1, and if we divide this polynomial by x minus a, where a is any real number, so this is a linear polynomial. So if we do this division, remainder theorem tells us that the remainder of this division will be simply the value of the polynomial at x equals a. So we have learned this from remainder theorem. Now let's say if it is given that the remainder is 0, then what does it tell us the relationship between these two polynomials? So let's take a look at some numerical examples that will help us understand this better. So let's say we take a number 12 and let's take another number, maybe 4. So if we divide this, we know that the remainder is equal to 0. So then what does it tell us? Well, it tells us that the number 4 fully divides into 12, or the fact that then 4 is a factor. 4 is a factor of 12, right? Because 4 fully divides into 12, so remainder is 0, and that means 4 is a factor of 12. So similarly, if we get remainder 0, if we divide px by x minus n, if the remainder is 0, that means we can tell that x minus a is a factor of the polynomial px, right? This is the first thing. Now, secondly, let's actually create a little bit of partition between our numerical example and the polynomial. Now, secondly, let's say if it is given, so this was the first scenario here, Now, secondly, let's say it is given that a number, in this case, let's say number 3, it is given that 3 is a factor of 12. It is already given to us. Then what can we tell about the remainder? Well, if 3 is a factor of 12, then when we do this division, we absolutely know that our remainder must be equal to 0, right? Because if 3 is a factor, we know it fully divides, leaving us with remainder 0. So if it is given that x minus a is a factor, if it is given that it is a factor of px, in that case we can simply say that the remainder must be 0. And we know from remainder theorem that remainder is given like this, right? So if remainder is 0, then we know x minus a is a factor of px. And if it is given that x minus a is indeed a factor, then from there we can conclude that remainder must be equal to 0. So this is precisely what factor theorem tells us. So factor theorem simply states that if px is a polynomial of degree greater than or equal to 1, and let a be any real number, then x minus a is a factor if value of polynomial at a equals 0. Now we know this is the remainder. So if remainder, in other words, is equal to 0, we know that x minus a must be a factor of px. We know that. And secondly, it says that if it is given that x minus a is indeed a factor of the polynomial, then p of a, which is basically again the remainder must be equal to 0. So as you can see, the factor theorem and remainder theorem are logically, absolutely, they are combined, right? So this is what the factor theorem is, and this is the relationship between the factor theorem and the remainder theorem.